everybody to the VTL presentation. Today our guest is Professor Alcardes. Professor André Ricardo Alcardes is a full professor of the College of Agriculture Luiz de Queiroz of the University of São Paulo in Brazil. He is graduated in agricultural engineering, and his master's PhD is in food science and technology by USP. And he also has a postdoctoral is a postdoctoral by National Institute for Agricultural Research in Montpellier in France. So the main research area is technology of production. His main research area is technology of beverages with focus on the production of sugarcane spirit. So thank you, Professor André. So start your presentation whenever you're ready.
Okay, André. Thank you very much for the invitation. I appreciate to be here today to talk about Kashasa. I don't know if you have ever heard about Kashasa, but we are going to talk about this spirit of Brazil. I will share here my presentation. Is it okay? Everybody see?
Yes, we don't see as a full screen. We just see your PowerPoint. If you want to put us a full screen, it would be better for everybody.
Is it okay? Is it okay now, André?
Not really.
I will try again.
Okay.
Stop. No.
No.
No, just a moment.
Okay. You can take your time. Now it's okay. Thanks. Professor, you are muted.
And now?
Now that's okay. Thanks a lot.
Okay. So I appreciate the invitation, André's invitation to be here today to talk about Kashasa. And as André said, I'm a professor in the Luiz de Queiroz College of Agriculture in the city of Piracicaba. It's in the state of São Paulo, in the southern coast of Brazil, here in South America. And my college is one of the most important institutions for tropical agriculture in Brazil. And I am the director of the Laboratory of Technology and Quality of Kashasa, in which we have some facilities to produce Kashasa, to study Kashasa, to study every step of production from sugarcane, and especially in fermentation, distillation, and aging. We have some equipment to the chemical analysis that is very important to confirm or to study the chemical profile of the spirit. in my presentation, I intend to cover the following points: cachaça, the basics about cachaça, definition, Brazilian legislation, some historical facts, the feedstock for cachaça, that is the sugarcane juice, and we are going to talk about the process with focus on fermentation, distillation, and maturation. And in my presentation, I will tell you some aspects about styles of cachaça and the sensory aspects of the Brazilian spirit distilled. So, by definition, cachaça, by definition by law, cachaça is a Brazilian spirit made from sugarcane with 38 to 48 percentage of ethanol in volume. Cachaça must be obtained exclusively from sugarcane juice. So this is the difference between cachaça and rum, Caribbean rum. That rum normally is made from molasses, and cachaça must be produced from sugarcane juice, submitted to the process, of course, of fermentation, distillation. I included aging, but aging is not mandatory for cachaça as it is for example, for cognac or bourbon or Scotch whiskey. For cachaça, aging is an optional step, and cachaça may be produced in pot stills, in single distillations, or in column distillation of the fermented sugarcane juice. So, cachaça is a typical spirit produced in Brazil. Only Brazil may produce cachaça. It's like, for example, cognac or champagne. Only Brazil, by decree, may produce cachaça. If any other country produce a similar spirit from sugarcane, it must be named as, for example, sugarcane spirit, never cachaça. And there are some requirements, some quality requirements that are established by our Ministry of Agriculture to establish the chemical composition in terms of volatile compounds and contaminants, and the quality requirements such as, for example, here, there are some identity and quality standards for cachaça established by our Ministry of Agriculture in terms of the maximum limits for aldehydes, total esters, total acids, total higher alcohols, the congeners in general, from 20 to 650, and for some contaminants. For example, ethyl carbamate, that used to be a problem in Brazil, and today we could solve this problem. And methanol, here we have some identity. There are more than these, but here you have the most important parameters for cachaça. So all cachaças produced in Brazil, of course, should obey these limits. Is it okay, everybody? Listen.
Yes, it's okay.
Okay, thank you. So let's continue. Talking about the history of cachaça. Cachaça has a long history of production in Brazil. Probably at the beginning of the 16th century, cachaça started to be produced in Brazil just after the arrival of the Portuguese colonists. The first product of Brazil was the raw sugar, the sugarcane for the production of raw sugar. Probably at the same time, cachaça started to be produced in the northeast coast of Brazil. And cachaça is the fourth most produced spirit in the world. About 800 million liters are produced every year of cachaça. And in Brazil, we have the large producers working with columns of distillation, but we have a lot of small producers, crafter distillers, spread across the whole country of Brazil, especially in the eastern half of Brazil. So we have more than 30,000 1,000 producers, different producers, small producers of craft cachaça in Brazil. There are more than 500 brands of cachaça, and of course, with a wide range of quality, diversity in flavors, profiles. Cachaça is very important socially and economical for Brazil in terms of the revenue and the jobs. And unfortunately, yet cachaça is mainly for the domestic market. In 2020, Brazil exported the less than 1% of the total production. And so most of cachaça are consumed internally in Brazil. And why? Because if you take a look for tequila, for example, in tequila, 70% of the production of tequila in Mexico is exported. The same is for Scotch whiskey. For cognac, for example, 98% of cognac is exported from France, and cachaça is only less than 1%. Maybe because we drink a lot, I don't know, but the reason is that the quality of cachaça used to be not very good. For example, here we show you some percentage of the brands of cachaça produced in Brazil until 2012 that were not in compliance with law in terms of the quality requirements I showed you in previous slide. Here's some works of our colleagues and some works of us. We could notice that half of the cachaça produced in Brazil were not in compliance, in accordance with the law until 2012. And I ask you to keep in mind this figure, 51% in 2012, because at the end of my presentation, I will show you the current situation in Brazil. That's very, very different. And we have facing a very very good improvement in the quality of cachaça. I'll show you at the end of my presentation. But because of this scenario until 2012, maybe explain why the exportation of cachaça is still very low. So, as an overview of the process of production of cachaça, so the sugarcane stalks are harvested, and then they are crushed in mills to separate the bagasse and the juice. The sugarcane juice goes to the fermentation process with selected yeasts or wild yeasts. And then the fermented juice we call wine or wash. The wine goes to the distillation process in pot stills or in columns. And then we have the white cachaça. We call it white cachaça. It's not white, it's colorless, but we call white cachaça. That is the cachaça, the fresh cachaça that could be consumed. When aging is employed in oak or tropical wood casks, in Brazil we have some tropical woods as an alternative to oak. And then after 1 to 3 years, then we have the aged cachaça. Of course, the three most important steps of production are fermentation, that's responsible for the production of ethanol and the basic aroma formation by the congeners. Distillation, that separate and recover these flavors compounds, and maturation, that depends on the time, the period of maturation, 1, 2, how many years of maturation, the chemical composition, of course, the flavor profile of the spirits may change substantially when maturation is employed. So let's begin with the feedstock. As I said, the feedstock for production of cachaça must be sugarcane juice. Sugarcane is a is a tropical perennial grass, tropical and subtropical perennial grass. In Brazil, we produce more than 600 million tons of sugarcane a year, and primarily used for the production of white sugar, or a material for the fuel, ethanol, for the cars, and also as a feedstock for cachaça production. Around 10 million tons of sugarcane are produced in Brazil exclusively for cachaça production. The cane is harvested without burning and should be transported to the distillery or mill as soon as possible, because of the perishability of the sugarcane and the sugarcane juice. So, entering the distillery, the stalks are crushed in rolls, washed to remove the remaining sugars in bags, and the fresh juice goes to the fermentation. But prior fermentation, the juice is strained and settled to remove some cane stalk materials, residues of stalks in the juice. And in Brazil, because of the perishability of the sugarcane and because of the maturation season of the sugarcane, normally cachaça is produced in the southern coast of Brazil, south of Brazil, from May to October, and in the north coast from December to March, depending on the period of maturation of the sugar cane that demands a dry season. So we have 4 to 6 months of production in Brazil. And the juice normally contains around 20% of fermentable sugar. This concentration must be adjusted before fermentation to 16 to 18 total content of soluble solids to go to the fermentation. And as we do not normally pasteurize the juice before fermentation, we not employ a heat treatment before fermentation, the juice carries bacteria and wild yeast to the fermenter, to the fermentation process, and some good flavor and bad flavors are produced. Sometimes the heat treatment is required in order to maintain any specific strain you choose. For example, selected or personalized strains that are used for the fermentation. And the sugarcane juice is based in sucrose. It's the most important, the main sugar in sugarcane juice is sucrose. That is easy to be converted in ethanol by the yeasts. And the juice is a good source of nitrogen and for the other required nutrients for fermentation. So it's a complete broth for the fermentation. Normally, we do not need to add any mineral or any vitamin to the fermentation process. So here we have a typical composition of the sugarcane juice in terms of sugars and minerals. So it's a complete broth. And in Brazil, there are producers that use use in fermentation the wild yeasts, the yeasts that follow the sugarcane juice. But there are, and is increasing the use of selected strains. We only have quite few options, like these two here from Lallemand, Canamax and Distillamax, are two specific strains good strains, sorry, for the production of cachaça. We could test these two strains in recent years, and you could see that they are very good for cachaça production in terms of the chemical and the flavor profiles of the spirits and the maintenance during the whole process. I'm going to explain how it is for cachaça. It's a fed batch process of fermentation with yeast recycling. So it's a very specific situation in Brazil. And when selected yeasts are used, the process is more consistent in terms of the congeners formed during fermentation. So consistency is very important for the production of cachaça and any other spirits. So the species of yeast is Saccharomyces cerevisiae. That is a very good yeast to the conversion of sugar into ethanol and the production of other congeners. Normally, the fermentation is very rapid, it's very fast at 30 degrees Celsius. And normally these strains used for cachaça production, they have a high tolerance to the stresses of the process that are very important because of our way of conducting the fermentation I'm going to show. So these strains present a tolerance to osmotic pressure, ethanol pressure, pH, and high temperature. As of course, fermentation is a biological process in which yeasts convert sugars into ethanol and congeners. That is very important for the flavor profile of a spirit. The congeners are more important than the water or ethanol. The flavor comes from the congeners. Yeah, so congeners generate the aroma and flavor of the cachaça and any other spirit. So we have to keep in mind that it's very important in fermentation. Besides ethanol production, the balanced production of congeners by the yeast strains you choose in your production. So the fermentation process is quite fast, around temperatures around 20 Celsius degree. The pH of the juice we call must is around 5, and after fermentation is around 4 because of the acids produced during fermentation. And from the beginning to the end of the fermentation, 12, 16, 20 hours is required to the conversion of all sugars in ethanol. As I said before, the process, the fermentation process is a fed batch fermentation in which the yeasts are recycled by centrifugation in industrial plants or by settle in craft plants between one fermentation and another. So at the end of fermentation, normally the yeasts are settled, and then the fermented juice or the wash or the wine, we call wine, is sent to distillation, and the fermenter is refilled with more juice, and an active fermentation is initiated very quickly because we have a lot of a great number of cells of yeasts remain in the fermenters. So we call these a long train of successive fermentations with a highly mixed culture of microorganisms. We have bacteria also included. So we needed to control these aspects. So here we have an illustration of the process at the beginning, the fermentation process at the beginning. At the bottom of the fermenter, we have the yeast cream, and then sugarcane juice is added to the fermenter until the fermenter is filled. So fermentation occur here. So at the end of the process, we wait some 1 or 2 hours, and then the yeasts settle at the bottom of the fermenter, and then here the fermented must is sent to distillation, and yeasts remain at the bottom of the fermenter, and then a new cycle initiates with more sugarcane juice or sugarcane must. So it's kind of continuous natural fermentation. So we have the recycle of the yeasts. Normally, repeat or restart with a new yeast strain is necessary after some weeks or some months. It depends on the producer and the quality of the process, how the process is cleaned. So, but normally it's necessary to restart with new yeasts after some weeks. Distillation is a step after fermentation in which we can separate chemicals in basis of their volatility and the affinity to ethanol. Normally, distillation for cachaça is made in pot stills, alembics, we call alembics, in copper pot stills, or in stainless steel columns, in order to increase the content of ethanol of the mixture, and also to separate or to select the good flavor compounds come from the congeners. We have the distillation stills could be pot still or column, and here we start the definition of some styles of cachaça. When cachaça is produced in pot still, the chemical profile is a little bit different from cachaça produced in stainless columns, continuous columns. We are going to see some data about this. So talking about the pot still distillation, the still is charged with the fermented juice, and then we proceed the cut points based on volume or in ethanol strength. Normally, heads cut is 1 or 2% of the charge of the still, where we have the most volatile compounds, and the spirit cut, the cachaça cut, is from 60% of ethanol to 38%, and the tail cut represents the less volatile compounds. Here we have the illustration about this process. Here we have the pot still, for example, 1,000 liters of fermented juice. The head cut is around 1.5%, 15 liters. The first 15 liters of the distillate, and then we cut and we recover the cachaça, the single distilled cachaça, and then when the spirit here coming out of the condenser is about 38 ethanol by volume, so we cut for the tail fraction that have the tail has some compounds that impairs the quality of the spirit. So this is the most common process for cachaça distillation in Brazil. And the head fraction corresponds to the fraction with high concentration of acetaldehyde, for example, the most volatile compounds, ethyl acetate and methanol, a contaminant, and the tail fraction is where we have the high concentration of acetic acid and furfural, for example. And we have some compounds that have a specific behavior in pot still distillation, that are the higher alcohols that, because their affinity to ethanol, they distill during the whole distillation. They follow the kinetics of the ethanol during pot still distillation, so we cannot separate them very easy in pot still distillation. And this illustrates the kinetics of some compounds during distillation in pot stills. So at the beginning, we separate the head fraction, here is in red, and then we recover the heart, the spirit fraction from 16 to 38. Here we have the curve for ethanol in green. That is very similar to the curve of higher alcohols in blue. And we have the tail fraction recovery at the end of the distillation. And so the head and the tail fractions are separated, and then we collect the heart fraction, only the heart fraction. That's the best fraction in terms of chemical compounds and flavor. We have several still designs in Brazil. There is not a standard pot still for cachaça production in Brazil, as it is for cognac, for example, production. The Charrentais alambic is standard for cognac, but in Brazil for cachaça we have different still design for the alambics, and of course any still design will define the profile of the spirit. So here we have for example here a pot still with a deflagmator here, with a column and deflagmator, with here we call the pot with hot head here. So we have different design of alambics, and of course with different profile of the spirit. And here we can define the styles of cachaça based on the production process. For example, distillation in pot stills. We may have the single distillation, as I explained, and we can proceed the double distillation for cachaça production. It's not common in Brazil, the double distillation, but some producers use double distillation in order to increase the quality of the spirit. So here we have the style of single distilled cachaça in the left, and then we have the double distilled cachaça in the right here. The single distilled cachaça I explained a few slides before, and the double distilled cachaça, the process is similar to the process used for the production of Scotch whiskey. So we have the first distillation, in which all the ethanol from the wine is recovered in the phlegma. Here we call phlegma it's similar to the low wines in Scotch whiskey, or in the brew wheels for the cognac. So the first distillation recovers all the ethanol, and then the phlegma here, or the low wines, or the brew wheels, goes to the second distillation, in which some cut points are employed. They are a little bit different from the cut points for the single distilled cachaça, because of the strength of ethanol of the charge in the second distillation. But we separate the head as well and the tail, and we collect the heart fraction in the second distill. And here we have a difference in terms of the chemical composition of the spirit produced, the new make spirit produced by single distilled process or this double distilling process. Normally, when we proceed double distillation, we decrease the total congeners of the spirit. So the concentration of the congeners in double distilled cachaça are lower than in single distilled cachaça. The same we observe for example for Scotch whiskey. The malt whiskey distilled in pot stills present more total congeners than, for example, the grain whiskey distilled in coffee column or in continuous column. So in cachaça is the same. Of course, the ethanol content is higher because of the double distillation. We have two distillation here, but the congeners have a lower concentration, so the double distillation produces a lighter spirit. And the double distillation solved the problem of ethyl carbamate in cachaça production. As I said at the beginning of my presentation, ethyl carbamate used to be a very important problem in our production because cachaças normally had a high concentration above the established by law, by Brazilian law and by other countries' law. And when we proceed when we use the double distillation, we could see, and we worked in this topic for 4 or 5 years in some past, the recent past in our research, and it could observe that the double distillation could reduce until 97% of the ethyl carbamate formed in the process. So we could solve the problem of ethyl carbamate in cachaça because the ethyl carbamate is formed during fermentation or during the first distillation. In the second distillation, this line in red here, the second distillation, ethyl carbamate accumulates in the tail fraction. So the spirit fraction, the heart fraction, is almost free of ethyl carbamate when we have double distillation. So we could solve this problem in cachaça in Brazil. And cachaça may be distilled for the large producers in column stills. Column still increase the alcohol strength of the spirit because columns are composed of several trays. Any tray is like one single alembic, a single pot still. So we have a lot of pot stills in the same column. And the removal, the congeners are easier to be removed in a continuous process. And we have, once again, we have a difference in style for cachaça produced in pot stills and in column still. So here we define the second style of cachaça in Brazil, and there's this different view of cachaça when cachaça is produced in alembic and when cachaça is produced in columns in Brazil. Normally, people prefer cachaça produced in pot stills. So here we have a different style of cachaça based in the equipment of distillation. Pot stills here in the right, and columns, stainless steel columns on the left here. Here we call the multi-stage columns and pot still distillation. And we could see in our research, because we used to research the distillation process, distillation equipments, and distillation methodologies. Sometimes in our university, we could distill the same the same fermented juice in different pot stills and in column of distillation, because we have a column of distillation in our facility in Exal, in our College of Agriculture. So we could define and see, you observe that in columns, the same fermented must originates a spirit with less total congeners than the same fermented must distilled in pot stills. So here we have the second difference in styles of cachaça. Normally, cachaças distilled in columns presents a spirit with less congeners. It's a lighter spirit in terms of flavor compounds. And after distillation, as I said, cachaça can be matured or aged in oak barrels or in barrels from tropical woods. It's not a mandatory step. So in Brazil, we have the colorless cachaça, the fresh produced cachaça, and then we have also the aged cachaça. So when cachaça is aged, it gains golden hues normally because they extract some compounds from the wood. The spirit extracts some compounds from the wood, and the sensory of the cachaça changed because of these non-volatile components extracted from the wood. And normally in aged cachaça, from 1 to 3 years, the sensorial quality of the spirit is based much more in the wood marker or the aging marker compounds than for the congeners formed during fermentation. So aging is very important in terms of changing the wood profile of the spirit. And currently, we have been working on research in terms of aging cachaça in oak and in tropical wood barrels. I'm going to show you the recent results we could obtain from our last investigation. So during maturation, there are some reactions that we call addictive, subtractive, and interactive reactions. So the additive reactions are based on the components released from the cask to the spirit. So the lignin derived compounds, for example. The subtractive reactions are concerned the evaporation of ethanol and water during maturation, the Angel's share. And interactive reactions are very important that because they are the reactions between the components extracted from the wood and the components of the spirit. So you have a lot of reactions and changings in terms of compounds, and of course, consequently, in terms of flavor and aroma of the spirit. Here are some flavors that are added to the spirit, not only for cachaça, but for whiskey or cognac, that comes from the wood. So you have some components with specific flavors associated with these components, extracted directly from the wood or for the lignin, and the transformation of these compounds during time of aging. It's important to note that the aging process is not linear. So at the beginning, we have a lot of rapid reactions, a lot of changes. And then at the end of maturation, or as maturation goes, there are some compounds that are transformed in other compounds, and the chemical of maturation goals in the subsequent years, and the companies are changed. And we normally, some compounds such as coniferaldehyde, for example, here in yellow, after some time, the coniferaldehyde is transformed in vanillin, the light blue here, and vanillin is transformed into vanillic acid, is oxidized into vanillic acid. So we have the transformation of these compounds, especially specifically the subject we have been studying for oak and for tropical woods in our currently projects. So another style of cachaça is based on unaged, the white cachaça, the colorless cachaça, and aged spirit. So both are cachaças, but they are very different in terms of flavor. The unaged and the aged spirits. But both are cachaças with different style. So when cachaça is aged, normally 1 to 3 years are used for cachaça into the casks, but we have cachaça with 8 or 12 years of maturation in wooden barrels for a specific period of time, normally 1 to 3 years in Brazil. And by law, there is a specification, a requirement by law in Brazil. Cachaça could be named as aged cachaça when half of the spirit was aged for not less than 1 year. So you have half of the cachaça aged for 1 year, and you can mixture this cachaça with a white cachaça, for example. And then we have the category of premium cachaça, in which the spirit is entire aged for at least 1 year, and the category of extra premium cachaça, the spirit, the entire spirit is aged, must be aged at least for 3 years in wooden cask. Oh, sorry. Is it okay? Are you seeing the slide?
Yes.
Okay.
Yes.
Okay. So another style of cachaça is concerned if cachaça is matured in oak. It's the most used wood for maturation or aging of spirits worldwide and in Brazil. But in Brazil, we have the tropical woods. So in 2012, we started the first project in which cachaça was aged in new oak barrels. We imported some oak barrels from France, the European oak and the American oak, and we stored or we aged cachaça in these new oak barrels for some time, and the results changed completely the concept about cachaça aging in Brazil. We could develop a new methodology to measure, to establish the aging level of cachaça, the aging degree, based on the lignin-derived phenolic compounds. This project was financed by our foundation, Fundação de Amparo à Pesquisa do Estado de São Paulo, here FAPESP, our foundation, and we counted with some partners in the Institute of Brewing and Distilling, the Bureau Nacional Interprofissional do Cognac, and the Scotch Whisky Research Institute with some analysis of the spirits. So it was a partner research. And this research was based in the transformation of the lignin compounds during maturation. So the branches, some branches of the molecule, lignin molecule, they originate some compounds. For example, the synapyl alcohol release the synapaldehyde to the spirit, and then the synapaldehyde is converted into seringaldehyde, and then this component is oxidized into the syringic acid. Another branch of the lignin molecule originates another synamic aldehyde, that is the coniferaldehyde, which is converted, depending on the time, into vanillin, and in turn, vanillin gives rise to for example, the vanillic acid during maturation. So it takes time to these reactions, and we investigate these specific reactions in cachaça aged in new oak barrels. And here I'm going to present you some results of our most recent research. We could observe the same pattern of kinetics of the benzoic aldehydes, the synamic aldehydes, and the benzoic acids during the aging time, as it is, for example, for any other spirit, aged spirit. So at the beginning, the synamic aldehydes are extracted, and then the synamic aldehydes are transformed into the benzoic aldehydes, and the benzoic aldehydes are oxided to the respective benzoic acids. So we considered both benzoic acids, syringic and vanillic acid, as aging markers, compounds for cachaça maturation. So they could infer some information about how old is the cachaça based in these aging markers, and not only in time, how many years cachaça is under maturation. It's not so important, or as important as it is the composition in terms of these benzoic acids. And taking into consideration the benzoic acids, the young distillates could be distinguished from the older ones. So the young distillates here from 6 to 24 months are easily distinguished from the old ones 4 to 6 years, based on the benzoic acids. So we could establish a new methodology to measure maturation time, and we could investigate both species of oak we have in our facilities: the American oak, the Quercus alba, and the European oak, the Quercus petraea. And for cachaça, in our conditions, we could observe that American oak barrels released as much as the double of total aromatic compounds to the spirit than the European oak. So here we have the total aromatic compounds, aldehydes and acids, and in gray here, in columns gray, we have the American oak, and in black columns we have the European oak. So in terms of concentration of total aging marks compounds, American oak was better to release, to supply cachaça with these aging marker compounds. And besides oak, we investigate some tropical woods, some Brazilian woods, as an alternative for oak barrels, because oak is very expensive in Brazil, because all oak in Brazil are imported, and also in terms of provide diversity or more complexity to the spirit in terms of compounds extracted from the wood. If we use different species, we have different components extracted from the wood, so we could enhance the complexity, the diversity of our flavor compounds in cachaça. So we could test it, we could research different tropical wood species. Here we have 9 of them. In red, the better wood for cachaça maturation. And we published in 2013, I guess, the first paper based in this research. And recently, we could investigate the lignin derived compounds in these species, in these tropical species, and compare them to the oak species. So in this paper, here we display the 3 tropical wood barrels, Amburana, Cabreúva, and Castanheira. And here we have the total aromatic aldehydes and acids that these wood provide to the spirits, compared to the oaks, European oak and American oak. And we could observe that Amburana cearensis is the species, could provide much more phenolic compounds to cachaça than, for example, American oak. So this is the subject of our current studies. We have been studying others tropical woods in terms of lignin-derived compounds, but we have here a very promising wood in terms of spirit maturation, that is the Amburana. So about sensory aspects, I have covered some of them. So the aromatic substance for cachaça comes from sugarcane, of course, fermentation, distillation, and this we saw the aging in wood casks. And based on these sensory attributes, we could develop a sensor wheel for the white cachaça, the colorless cachaça, based on sensations, specific sensations and tastes of the cachaça, and for white cachaça, and for aged cachaça, matured in oaks and in tropical woods. So here we have some attributes that is usually observed for cachaça matured in specific woods. So I'm getting at the end of my presentation. And at the beginning, I presented this slide. I asked you to keep in mind that until 2012, half of our cachaças were out of the law, the specific law. And here we have the current results for works of our laboratory and the laboratory of some colleagues in Brazil. So from 2012 to 2019, we could observe a drastically reduction of the percentage of brands of cachaça not according to the law. So data from last year, 2021, in our laboratory, we could see that only 1% of the analyzed cachaças that we analyzed in our laboratory, only 1% was not according to the law. So 99% currently, nowadays, are into the law, are according to the law. So the quality of cachaças have improved very fast over the last 10 years, I'd say. And some brands of cachaça emerged of this scenario in terms of quality and in terms of maturation in new oak barrels or new tropical wood barrels. So here we have some examples of cachaças sold in Brazil. I put the value and the prices in American dollar. So here we have some examples of cachaças available in our market, and the prices here, 3. Here we have some other cachaças. Here, more examples, and here. So, based on the spirits worldwide, nowadays I'm very comfortable in include cachaça among these high quality spirits in the world, because cachaça has been respected over the last 10 years and enjoyed worldwide, especially due to the improvements in quality, in process. So today cachaça is one of the important, I'd say, and high quality spirits in the world. And the International Wine and Spirit Records predicts that there is a growing interest in sugarcane spirits, based spirits, in high quality based spirits. So cachaça has an opportunity. As our exportations are very low, we have a potential for growth, and we have been observing growing interest in cachaça in European and American markets. There are some international spirits company interested in importing our cachaça distribution abroad. And the most important and the most high quality cachaças in Brazil are based in maturation in oak barrels and tropical wood barrels. So they are attempting to adding quality and a premium image to this spirit to be compared to whiskeys and cognacs. And as some conclusions of my presentation, cachaça is a sugarcane juice based spirit. The process, fermentation, distillation, and maturation, modulates its sensorial quality. So you have the styles of cachaça, different styles. Cachaça has improved its quality over the last 10 years, I'd say, because of the technology. It was the technology that was used for production. And cachaça is searching an opportunity in the international market share, and the international share for cachaça is increasing very slowly, but is increasing. And to end my presentation, I don't know if you have tried caipirinha. Caipirinha is a Brazilian typical drink prepared with cachaça, white cachaça, colorless cachaça, lime, sugar, and ice. It's a very good drink. You should try sometime caipirinha if you haven't yet. And I'd like to thank you for your attention. I'd like to thank you for the invitation, André, to talk about cachaça. And here is my email address. If you have any doubt or any comments or anything you want, you could send me an email, and I would be very glad to talk to you and explain a little more about cachaça.
Thank you, Professor Alcarde, for your great presentation, and thanks. We really appreciate your experience and your work. It was a great work increasing the quality of cachaça in these past years. Let's see if one of the people, the person in our audience, has questions. So Javier, please.
Hi, Professor. Thank you very much. Nice presentation.
I have a...
I have a couple of questions about the process itself. Yeah, because I'm working with the same here in the lab, but with another substrate. I would like to know if you do some agitation process in the fermentation feed batch that you do. I would like to know what is the yield that you are getting with that process that you are doing, because I working with batch. I'm more or less reaching around 18, but I'm trying to improve in that. And also to final, I would like to know if you are doing something with the vinasses, because I know that after the distillation process, you have a huge amount of this waste, as you say. Thank you very much.
Okay, Javier. From your last question, the vinasse, normally vinasse in cachaça is 1 liter of cachaça generates about 8 liters of vinasse. Normally, the producers in Brazil use this vinasse as a fertilizer irrigation. They send the vinasse back to the fields of sugarcane.
Okay.
In terms of fertilization and irrigation. It's a source of potassium, very good.
Okay, you don't have any problem with glycerol in that vinasses, because I know that glycerol is a byproduct of this fermentation process normally.
No, it normally is, I don't know if I got your question, but normally the producers, the small producers, are allowed to send the vinasse back to the field. And you asked something about the fermentation yield, is that right?
Yeah, the fermentation yield, yeah.
From the strains we use for the strain yeasts, normally we have from 86 to 89% as a fermentation yield in terms of sugar converted into ethanol.
Okay.
For the fed batch fermentation.
Okay. Thank you very much.
Thank you.
Thanks, Professor. I have also one question. How do you track? You told in your presentation that during the fermentation you reuse a lot the yeast. Does it keep constant efficiency? And about this decrease, how much decrease it should have to replace the yeast?
Very good question. Normally we evaluate the viability of the yeasts during recycling, and normally when it's below 80%, we restart the process. But there are some other parameters such as pH, acidity, and the bacteria counting that help us to take the decision of replace the yeasts. Normally, when we face some problems such as full-on production or a different behavior of the fermentation, so we decided to change to restart because it's quite easy to restart. We use the selected dried yeasts. So after one cycle of fermentation, the yeast population increases 10 times. So and in Brazil, it's not expensive. The yeasts to buy a new strain or a fresh strain. So normally, I suggest the producers to change the strains every week or every 2 weeks. Normally, they keep the yeast strain for four weeks normally, but 1 week it would be the best scenario. 2 weeks, okay, but after that, the consistency decrease.
Okay, I get it. I got another question, guys. So, Professor André, thanks a lot for your great presentation. For sure, I'm going to email you with some questions because I also work in this field here in the LBT. And we really appreciate your presentation and your availability to be here sharing your experience with us. So thanks a lot. And please, if you need anything, count on us too.
Okay, André. I appreciate the invitation. I thank you very much. I apologize for my English. Sorry.
Don't be sorry. It's not necessary.
I did my best, but if you have any doubt or any comments, please feel free to write to me. And once again, thank you very much for the opportunity, André. It was a pleasure to be here today with you guys, everybody.
Thanks a lot. Bye,
Thank
Professor.
you, Professor.
Thank you.